Okay, if you recall in our previous class, we have discussed the system components. We have read about the different system components starting from process management, memory management, file management, IO management. Then we have secondary storage or disk management, networking, protection, command line interpreter, all those, and graphical user interface. All these we have read for the system components. System components are nothing but these are the functionality that is being provided by the operating system. So today we'll go for one of the important topic is the system call. Although I have already
Sir, can you please tell about the command line interpreter?
Command line interpreter is nothing but a like in your Windows, you have everything is in form of graphics where you double click and start a graphics program. However, there are some operating systems which provides command line interpreter, like in Unix, in Linux, that you are doing on the lab. In your lab, what you are doing, you are giving some command and it is giving you the output. That is a command line interpreter, or we say it is a CLI, command line interpreter. In Windows also you have command prompt is there where you type some commands and you get the result over there. So in command line interpreter, what you have to do, you have to remember, you have to type the command over there. Whereas in graphics user interface, these are the commands or executable files are in form of icons. You just have to double click over it to start. Correct? A file or a folder or a program that can be just double click over it and start. Where in CLI or command line interface, you have to type the command. You have to remember and type the command. Is that clear?
Yes, sir.
Okay. So these are only interfaces. Why I say interface? Because how do you give the command? Either by typing or by clicking. So if you are giving by typing, it is a command line interface. To click something that is being displayed, then we say it is a graphic user interface. So in most of the operating system, they provide both GUI and CLI. Like in Linux, you have GUI and CLI. In Windows, you have GUI and CLI, right? So today we are going to read an important concept of system call. Actually, this will be the last topic of this module from the module 1. This is the last topic is the system calls. Here, what you have the the brief or the system call I have already told you. System call is just like an interface. I have shown you one diagram over there. If you could remember, this is the diagram I have done that. You have some programs are running, user programs or system programs are running. These are the different services provided by the operating system. So this is operating system in which operating system provides different services. What are the services provided by operating system? Already we have discussed process management, file management, memory management, IO, disk management. Those are already we have discussed. These are the services that are being provided. And user wants to avail these services. User wants to access these services. User want to create a file, close a file, open a file, see the status of the disk. These are the request by the user or system program. What is his request? Request is to get one of the service of the operating system. So how it will be done? It will be done through these system calls. So there are various system calls already available. So it will invoke one of the system call to get the work done. Correct? So that we will be discussing over here. Here it says programming interface to service provided by the operating system. So services by the operating system is provided by whom? Through the system calls, right? So these system calls are usually written in high level language, C or C++ language. These are usually being written in C or C++ language, right? Sometimes it is being, we say it is although it is written that it is a high level language, but these interfaces what is being written in C and C++ is actually in low level language. Anyway, so we are saying that C and C++ are high level, so we say it is a high level language only. But those are being written in form of low level programming. So each system call is associated with a number. So we may have a number of system calls for opening a file, closing a file, see the status of the file, to what, to create a new file, to check the memory, to create a process, to delete a process, allocate memory. So all these are one system calls. Is it understood? So there may be a number of system calls is there in the operating system. So if there are a number of system calls are there. Suppose I have 100 number of system calls. So in return to every system call, there is a small program which has to be executed. Suppose I call a particular system call, I go for invoke a particular system call. In return, that will invoke a small code. If I go for open system call, in return to the open system call, some lines will be executed, right? So I have a number of system call. Every system call has a ID, has a number. For every ID, there is a small code to execute. Correct? Now it says mostly these system calls are accessed by programs via a high level application programming interface, or we say is a API, rather than direct system call in use. Again, we have a hierarchy over here. It says that instead of directly calling the system call, directly going for a system call, we may use it through an application program interface. Try to understand. It says that program will use the system call so that it will interact with the it will get the service of the operating system. But it says that usually it goes through a high level API, because it will be, I will tell you that two advantages are there anyway. So it goes through an API so that it will be easier for the program to write a program for a API, right? So direct system call need low level programming. See over here, direct system call need low level programming. So although you are writing in C language or C++ language, actually we are writing a low level programming over there. So direct system call need low level programming. Generally in assembler, low level programming means we write the assembler code for the same. Correct? So user need to know target architecture and cannot create CPU independent code. See over here, I am writing a low level programming. So that means I have to write looking into that architecture of the machine. Suppose for my computer, I am designing a low level program, then I'll see this my 32-bit machine, 4 GB RAM, and this is the looking into my architecture, I will go have a low level program. So that makes that program makes system dependent, that makes my CPU dependent. But I want to run the code across the other machines as well. In that case, I want my code to be independent, CPU independent. It should not be dependent on the architecture. In that case, what I'll do, I will take the help of this API. So API will run over there, which will convert your code to the machine on which it is running. The machine on which it is running. If you must have read the Java programming, in Java programming, you must have read about JVM architecture, or in Python, you have PVM architecture. So what is that JVM does? Whenever the bytecode is received, the compiled code is received, it look into the system architecture and convert the low level code by looking into the architecture on which it is running. Is it understood? Similarly, what it does over here, if I have an API I am using, it converts to the system independent, so it can run on any machine because the API is running on that particular machine. So therefore, it is written the direct system call need low level programming generally in the assembler, and user need to know target architecture and cannot create CPU independent code. Correct? Some of the most common API, we use Windows 32 API for Windows. We need POSIX API for POSIX based systems, Java API for JVM. These are generally being used as the API. Mostly you must be knowing about this Java virtual machine, correct? Okay, is it understood? Any doubt over this? Is there any doubt on system call or the API? Okay. We'll go for an example. We'll see an example that how actually the system calls are being made. We'll take an example. Suppose the example is system call sequence to copy the content of one file to another file. Usually what you give in Linux, suppose I'll say copy a file to another file. What do you do? cp source file name with path space target file name with path, so that the source will be copied to the target location. But when you give this command in the command interpreter, in command line interface, you give this command cp file x space y, so x file will be copied to y. In when you this command, this is only one command, but to execute this command, a series of system calls are being made. To execute this single command is very simple command cpx, y. A series of system calls are being made. Call sequences, we say. Call sequences are being made. Which call sequences? System call sequences. What are the system call sequences that are being made? For example, for copy to one location, another location, acquire the input file name, write prompt to the screen, accept the input, acquire the output file name, write prompt to the screen, accept the input, open the input file. If the file doesn't exist, then it should abort. We'll create output file. If it exists, if the file exists, then abort. And then go for again loop, means it will go for the reading the next character, and like it will continue. Then read from the input file, write to the output file until read fails. So this loop will start from here, read from input file, write to the output file. So until read fails, this will continue. Then when it is over, close the output file. Write the completion message to the screen, terminate normally. Just see over here. You are giving one command, you are seeing that how the command has given you the output. But to execute that command, there are various system calls are being made. Various services of the operating systems are required. It need to get the input file name. It need to get the output file name. It need to get accept the input and output. It should open. You see how many system calls are required. So every operation or each operation that we do, for every operation we have different system calls. So we have different system calls. One second. Okay, so system call is an explicit request to the kernel. It is a low level mechanism. System call is an explicit request to the kernel. It is a low level mechanism. So actually why it is a low level mechanism? Because we are not writing the these codes for the operating system. Operating system has a set of system calls already defined, correct? So what we are doing, we are invoking some of the system calls over there. However, API is high level mechanism. We may not have, we may not directly invoking the system call, but we can invoke this API. Then API is designed in high level. So we could easily design our API, we can modify our API, or we can have some new APIs in our system. Okay, so we use API in high level programming to invoke system calls in low level architecture. See over here, the API is high level, system call is a low level mechanism. So what do? We use API in high level programming to invoke system calls which is in the low level architecture. Is it understood? The system call is in low level architecture. We use a high level API to invoke those system calls.
Sir, can you explain again?
Yes. This slide you are talking about. Okay. Just
Yes,
see.
sir.
Okay. See over here. The system call is where actually system call is implemented. Try to, if you go for this figure, you will understood better. See over here. The system calls are being implemented here by the operating system so that it will get these services. To get these services, the system call is implemented over here, which is usually in low level language. So user program usually cannot write the low level program always. Always the user cannot write the low level programmings. To facilitate the user to write in high level language, we have API over here. So we have API over here. Are you getting me? So API is in high level language. So now previously what we are saying? We are saying that this is user code and this is operating system. This is a system call. Now you are saying that between these user programs and to invoke this system call, I will have a API over here. So I will have a API over here. And this API is in high level language. System call is in low level language. Usually the system call is in low level language and API is in high level language. So user could able to write in high level language programming. Is it understood or not? Is that understood?
Yes, sir.
It's a
Okay. So now we'll another example of API, example of a standard API. So if you go for a Unix system or Linux system, I want to see that what is the API, for the function. There is a function, suppose read function is there. I want to see that what is the API, what is written inside the read function. In read function that is available in Unix or Linux. See, if I want to get the help of this, I just write man read. Man function is to get the help of any command, so I write the man read. And you will find the description of that. In that file, you will get many things over here. You will find read function takes 3 arguments. One is the file descriptor, the buffer size, the number of bytes to be read. After reading, how many bytes are being read, it will be returned over here. The size, the return type is being mentioned. So the detail is being mentioned over here, correct? And this, what is written, it is in form of a high level language. So an API, it is a set of functions, objects, or protocols or data structures for the support of application development for developers and programs. So these functions, what we can see over here, it is easy to read and decode over here. So it is a set of functions, object, protocols, and data structures for the support of application development for developers or programmers. When the programmer or developer will try to develop an API, he could able to develop it easily if it is in a high level language. So it is just a set of functions or some data structures or some protocols or objects we are using. It is actually a kind of function. It is actually a kind of function definition which specifies how to make available of a specific service of the operating system. We have already discussed this. It says it is a kind of function definition. So we are actually defining a function. For what we are defining? One of the service of the operating system must be available. Our main objective is to how to avail a service of the operating system. So how to make available of the operating system, we are writing the code for the same in API. So APIs are available from library or from operating system itself. So we may write API, it can be available from the library or from operating system also provide some of the APIs. Whenever a programmer need a specific service from operating system, he or she can use appropriate API to do that. If somebody wants file operation, he may access a particular, he can use a particular API. Somebody is using some other operator, maybe memory management, maybe using the another API over there. So appropriate API may be used to avail a particular kind of service. This is the system call implementation. This is the system call implementation over here. This diagram is important. See, this is my user application. Try to understand. This is my user application. There are a number of system calls present over here. Why these system calls are there? Because if I invoke any one of the system call, it will do a particular task. These system calls are to get a particular service from the operating system. So this part, the lower part is the operating system, that is the kernel mode we say. This part is the kernel mode, correct? The upper part we say is the user mode, the user application runs. The upper part is the user mode where the user application runs. Lower part is the kernel mode where your operating system is residing. So to avail any of the service of this operating system, it has to invoke a particular system call, correct? And these system calls are being numbered 1, 2, 3, 4 like being it is being numbered. And for every number or for every system call, there is a small function over there, small code over there. Is it understood? Like you go to a restaurant. In the restaurant, the kitchen itself, we can think of as a kernel mode which we cannot see. We cannot see visible what is there inside the what is going on over there. User is just sitting on a table and over here. But what the user wants, what you want a particular application, you want a particular food item. So a menu will be given to you. A service menu is over here. These are the services that are being available. You have to select a particular service. Suppose the user select the open function. The user selects the open function. Open function has an ID. Open function, suppose this is the system call number 15. Let the open function is system call number 15. So this open function in return will go to the 15th number in the system call sequence. This will go to the what? To the 15th serial. Understood? So once it reach over here on the 15th serial, then what it will do? It will invoke the corresponding code which is being designed for 15. Suppose 15 is the open function, and for open function it will invoke that particular system call. So that means invoking this system call means I am availing the service. After availing that service, I must go back to my application so that next instruction will execute. So I will return back from here and go to the user application to do my job. Is it understood? So if you consider the previous example, suppose it is supposed to first one is while to copy from one file to another file, first one is to acquire the input file name. So it will get the input file name. It will suppose get is the function. It will come over here. It will invoke the get function. It will go back. So it has got the first one. Then again it will go for this one. Write the prompt on the screen. Then it will come over here, and accordingly it will go. So for every operation, it will invoke one system call over here. Every system call has a ID, has a unique ID and the corresponding code for the same. Correct? So this diagram shows how the interface is being, your system call interface is working. The lower part is the kernel mode or operating system mode. This is your user mode. So typically, a number is associated with each system call. Is a unique number actually. A unique number is associated with each system call. Correct? The system call interface maintains a table indexed according to these numbers. So this interface, what it does, it has a table actually. Suppose I have 100 number of system calls are there, so these IDs are being maintained over here. So I have a table which is have all those 100 system calls addresses are being kept. System call 1 is at memory 100, system call 2 as 150. So the system call along with where it is being stored, it is being maintained in a table. Correct? So the system call interface invokes the intended system call in OS kernel and return status of the system call and return values. So what it does, the corresponding system call is made, it is executed and returns the status, whether they successfully executed or there is some error or whatever, or some values may be returned. The caller need know nothing about how the system call is implemented. So user doesn't know that how it is being implemented, which system call is being called, how it is being returned. This is not known to the user. Correct? So this is not known to the user itself. The caller need know nothing about how the system call is implemented. This doesn't require at all, because user wants his work to be done only. So just needs to know nothing, just needs to obey API and understand what operating system will do as a result of call. So it must know that after invoking the call, what it should return me. If I am reading a file, it should return me how many bytes I have read. If I am opening a file, it should return me whether file is opened or not. If I am deleting a file, it should give me whether successfully deleted or not. So it is actually it is actually interested for the response rather than how it is being done. Correct? So just needs to obey API and understand what operating system will do as a result call. Most details of operating system interface hidden from programmer by API. So the details of operating system interface are being hidden from the programmer by the API. How it is implemented, it is being hidden by from the user, because it is going through the API only, right? So managed and runtime support library. Runtime support library is the set of functions built into libraries included with the compiler. Some of these are being included in the compiler itself. So we can just invoke it, invoke the API through the API. I can go through the system call and we can get over here. Correct? So this is being hidden through the how it is being implemented. This is being hidden through the API. So instead of writing low-level programming, calling the low-level programs, I can go for invoking the API itself. So what is the advantage? Advantages I will tell before. But see over here, the same example I have just having in this diagram. So see over here, we have some user application. That user application, for example, this is the user application. I have a user application, integer main. I have, this is the function. Suppose this is my program. This program I want to execute. So I am executing this program in which mode? It is in user mode. Correct? So any program that you are using, maybe a database program, Java program, C program, whatever, those are all user mode. But whatever you are doing, you are writing printf, scanf, whatever doing, for every command, what you have, a series of system call will be there. For example, printf statement, then it should get what? It should get the output device, status of the output device, it will make ready the output device, get the input, that is greetings to be printed, send it to the output device, print it, character by character. So there are a series of system call will be made for only one statement even over here. So suppose this is the command printf statement over here. This has to go to the standard C library where the API is being implemented. Here the API is being implemented. And it knows that write function to be called because it has to write on the VDU. Write function is called. So write system call will be called. So is it understood what I am saying? This is my program. I have a printf statement. So printf statement needs to write onto the screen. So this is being implemented in the C library. As I said, this can be implemented in some of the runtime support libraries, or either you can have a C library or you have an API over here that knows that it has to invoke write function. So now it will go for what? It will go for this write function, invoking the write function to a particular location. So it will go for calling the system call write. As you know that once the write function is called, this write function will go to what? To search in this table. The table has all the system calls and this address. So it will get the write function somewhere. Suppose here it finds the write function. And it will go for invoking the write function itself. The way it is being invoking open function, similarly the write function will be invoked. Correct? So this is in the middle, we can say this where you are writing the system call interface. Now you have a standard C library or API over here, which in turn make a system call. So writing in this library is quite easy as compared to writing directly in the low level language of a system call. Is it understood or any doubt for these two figures? Okay. So what we have seen, so we have now the layer is now, this layer is now being a new layer you can think over here is the API. Now you have initially we have user program hardware. These two was there, user program hardware. Is it or not? After user program and hardware, we have introduced an operating system. We have introduced operating system. So user program, operating system, then hardware. Correct? This user program may run multiple programs over here through interfaces. So through a user program interacts through user interfaces. So this is being introduced. Try to see that how the hierarchy is being increasing. Initially we have user program, then we have another end is the hardware. In between we have introduced the operating system, and we say that operating system is like works like a bridge between the software and hardware. That is in our definition. But now in between this operating system and user program how they will interact? They will interact through some user interfaces. So now you have user programs interact through user interfaces to the operating system interact with the hardware. Then we have what is there inside the operating system. There are many services actually they are availing. So user interfaces should avail the services of the operating system. So service is one layer over here. So it says the user interfaces will avail the services, but in between that we have some system calls. So user interfaces use the system calls to avail the services of the operating system. Then it says system calls are low level programming. Why not we will go for some APIs? So user interfaces invoke some APIs which will call the system calls, invoke some system calls to get the services from the operating system. Is the hierarchy understood? So we have these user interfaces uses some API, and API knows that which system calls to make, and those system calls are being made so that a particular service will be available by the by the user or by the application program. Right? Now, why would an application program prefer programming according to an API rather than invoking the actual system calls? Why would an application programmer prefer programming according to an API? Why it is required to prefer API according to API it is required? So invoke rather than invoking the actual system call, why it will go for this API? The first thing it says that programming portability. First is the programming portability. An application program, a programmer designs a program using an API, expect his or her program to compile and run in any system that supports the same API. When a programmer is writing a program, he is expecting that his program should run on any other machine where the API is present. Where the same API is present, it should run over there. So I want my program to be portable. In that case, what I'll do, I will have an API. The API will convert into machine level language on which it is running. So I will run that API wherever in that API is running in any of the machine, that will convert to its own architecture on which it is running. So this gives a portability, program portability. The program designed in one system can able to run in other systems, any other system. That is the program portability. But do remember, when I say it will run on other system, this means that the other system should have the same API. If you are thinking that you are invoking a Java program or saying there is a machine independent, because that program is running on another machine where the JVM is present. If the JVM will not be there, then it cannot convert into that machine code. The same API has to be there. That makes the code to be system independent. Correct? So actual system calls can often be more detailed and difficult to work with rather than API available to the application programmer. So actual system calls are often more detailed and difficult to work. If you are working with the low level language and for accessing and using those programs is somehow difficult, right? So it is better or easier to use the API program because the APIs are written in which language is in high level language. Is that understood? Anyone having doubt about this program portability or the use of API? Okay, so now question is that how this will be called? How this? Suppose I need to pass some parameters. I need to pass some parameters to the to the system call. Suppose I want to open a file. I want to give the file name. So file name is a parameter. So sometimes we want to do some operation which needs parameters. How do you pass parameters to a function? How do you pass parameters to a function? I'll explain this slide. Let me explain over here. I want to have a X. I have a parameter call over here. I want to call system call 13. I want to meet. This is your operating system. This is your user program. I am running a program. This program needs the system call 13 to be invoked, which is there in the operating system. This is the code for system call 13. Are you getting me? This is a user program. This is the operating system. This needs the system call 13 to be invoked. So that's a parameter. So here it requires a parameter, that is the X parameter, to pass over here. X is the parameter for call. So how this parameter X will reach over here? It says that one of the ways I can put it in a register, a specific register in which I will put that that parameter. So if any parameter is required for the system call 13, it will get it from that register. This is very simple. But if I have more number of parameters, X, Y, Z, or array of parameters, what I will do? I will put it in a table or a block, and the starting address I will keep it over here, so that this will get the starting address from which it can get the values. Is it understood? One method is by passing through the registers. Parameter can be passed through registers. Second one, the parameters can be passed through what? Table or block. Third one also we can pass it. We can have a stack over here. We can implement a stack so that we can push it to the stack, and whenever required we can pop it and use it over here. So three different way the parameters can be passed to the system call: through registers, through table or block, through what? Through a stack. Correct? So that is written over here. Often more information is required than simply identifying the desired system call. Exact type of amount of information varying according to the operating system and call, that is required. So three general methods used to pass up parameters to the operating system. What are those? Simplest is pass the parameter in register, that I have done over here. I put it in register, it will get it from there itself. Second one is in some cases maybe more parameters than register, so we cannot put a register if more than one parameters are there. So parameter stored in a block or table in memory, and address of the block pass as a parameter in the register. So what I can do, I can put in a block or table, and starting address I will just keep it over here. This approach is taken by Linux and Solaris. In what else we can do? We can push it into a stack. Parameter placed or pushed into the stack, and the program are popped up the stack by the operating system, so it will take out from the parameters from this stack itself. Correct? So block and stack methods do not limit the number of length of parameters being passed. So it is not limited that how many number of parameters you are passing over here. But in the register you have a restriction, one parameter is over here. But although this is fast, very fast, but we have a restriction that only one parameter can be passed. So do remember there are three different ways the parameter can be passed to a function. Is it understood, or anyone having doubt? So this is the way the parameter is being passed. There are different types of system calls are there. I said there are various system calls are there, 1, 2, 3, 4, like what are these system calls? Some are for file management, some are for process management, some are for memory management, some are for disk management. So we'll have a number of system calls for different purpose. So those are listed over here. For process management, creating process, terminate process, end, abort, load, execute, these are event, wait for time. These are the system calls for process management. File creation, file deleting file, open or closing file, read, write, repositioning, get and set the attribute of the file, these are file management. So these are the system calls required for file management. These are the system calls required for device management, requesting device, release device, get device attributes. These are device management. We can have some system calls for communications, communication, creating communication, create, delete, open connections, shared memory model, shared memory, attach, information maintenance, get time, set time, and the protection from what like control access to the resources, get and set permissions, allow or deny resources. So the system calls are categorized into these 6 categories: process control, file management, device management, communications, information maintenance, and protection. So all these system calls are being categorized and put it into different headings only. So these are various number of system calls are there. These are the examples of various system calls. These are various, the process, what are the, some of the system calls we will read over here itself. In our lab we will get these system calls. Is it understood? So this is for today's class. It will over the module 1. So if you have any doubt till now you asked, let me first take the attendance, then we have the doubt. We'll go for the doubt. Roll number 2 is permanent absent. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 20, 22. 22 is also permanent absent. 25, 26, 27. 25, 26, 27. 28, 29, 30.
Sir, sir, 26 present.
26 present.
Yes, sir.
Okay, 30, 31, 32, 33, 34. 37, 39, 41. 61, 73. Okay, let me tell once again the absentees roll number which I didn't get over here. Roll number 2, roll number 22, 25, 27, 30, 37, 39, 61, 73. If you have any doubt, now you may ask me.